Yes, I think all looks good. Hi guys, a very good morning everyone. Very good morning and welcome to the new initiative that is Super Sundays. Yes, let's utilize Sunday. Okay, so this Super Sunday, we are going to have a general aptitude practice dose, and the practice that we are going to take today is time and work. Of course, this practice dose does not mean that I'll directly take up a question and start solving it. Yes, we'll do that, but with every question we will learn the concept, because aptitude is all about practice, but with the practice required techniques, tricks, concepts. I'll keep telling you, okay, so that one by one multiple topics get covered for you. Okay, and it is not just one Super Sunday, every Sunday. Okay, every Sunday we will be planning some or the other topic for practice dose. Okay, for practice dose, and the Sunday sessions will be mostly aptitude or maths. Okay, other than that, the technical sessions I'm planning on weekdays. Very soon you will get the technical control signals, etc. Those sessions also will be having. Okay, hello. Is the audio low? Maybe my own audio might be low. It might not be the mic issue. Okay, because I was not well for the last 2-3 days. Somehow, I had planned about Super Sunday, so I thought of taking this. That is why you might see there was one more session. That is the 65 plus target in GATE. Okay, that I had to postpone because I was not well. I was down with high fever for the last 2-3 days. Okay, so maybe my internal voice itself may be low, but let me still check it up if you guys are telling it. I planned about 2%, so I thought of taking this. That is why you might see there was one more session. That is. No, guys, I don't feel at all. I don't feel. It's fine. It's clearly fine. I just heard it in my system also. Okay, so it looks totally fine. It looks totally fine. Okay, so yes guys, let's get started with the first Super Sunday for GATE 2025. And now guys, because we are taking aptitude, it's not specific to GATE. Okay, you may be preparing for GATE. Okay, you may be preparing for engineering services. Okay, or any other technical exam or AE exams. Okay, like you have Transco exam upcoming. Okay, you have the PSC AEE examination for AEE. Okay, so for all these examinations, okay, later on, suppose ISRO notification comes, you might be preparing for ISRO. Okay, so for any of the exams you prepare, you are going to get the benefit out of this session. That is the reason I've not mentioned specifically to GATE. In every such exam, this is going to help you. And timer work is a very common topic, of aptitude, right? So let's get started. Let's get moving ahead. This is a regular intro about me. I hope you are aware. Okay, so now when we talk about time and work, just a second here. Just a second here. Okay. So when we talk about time and work, there are two important concepts onto which every type of question can be solved. Okay, number one is the concept of efficiency. I'll tell you which concept to be applied where. And second is the concept of product constancy. Okay, these are the two concepts. If you conquer them, all sorts of question, easy, moderate, difficult, any sort of question can be easily conquered by you. So when we talk about time and work, there are two important. Okay, chalo, let's get started. So of course, when I'm telling efficiency first, let's talk about efficiency. Okay, and then let's go to product constancy. Okay, let me start with the question. Alex can do the first basic question, two persons only. Okay, Alex can do a job in 12 days. Okay, Brian can do the same job in 6 days. Okay, same job. It's about same work. Okay, in how many days can they complete the job working together? In how many days can they complete the job if they are working together? Okay, now dear, for two persons working together, actually it is very easy to solve. If it is two persons working together, okay, you can directly, I'll tell you how, but you can directly do 12 into 6 divided by 12 plus 6. Okay, xy upon x plus y. Okay, working together, working parallelly. Together means parallelly. So like you know, parallel resistor formula R1 R2 upon R1 plus R2, like that you can remember. At least ECEEIN guys can remember this way. Na? Okay, what is the parallel resistor formula? Okay, resistors in parallel. Okay, so R1 R2 upon R1 plus R2, here it is same. Okay, two people working parallelly means together. Okay, so 12 into 6 upon 12 plus 6, that is the answer. But I will explain you why. Okay, this is equal to 72 is divided by 18 and this is equal to 4 days, right? This is equal to 4 days. Okay, so working together. Okay, working together means working in parallel. Okay, working together means working in parallel. Okay, so you can remember this way, R1 R2 upon R1 plus R2. Okay, and sometimes, okay, why I'm telling you the special formula is sometimes you get direct question. Okay, before I explain you the concept, I'm telling you, first concept I will cover here is efficiency. This one, efficiency. Okay, but before I cover that concept, okay, just have a look into it. See, look into it. A GATE direct 1 mark question on the similar concept. So sometimes there are on the two bodies. Okay, like it takes 2 hours for a person X to mow the lawn. Y can mow the same lawn, means same work again. Okay, in 4 hours. How long in minutes will it take X and Y if they work together? Okay, if they work together to mow the lawn. If they work together to mow the lawn. Okay, right? So again they work together. Okay, so again what is the formula you will apply? XY upon X plus Y. So 2 hours and Y take how many? 4 hours. So 2 into 4 is divided by 2 plus 4 and that is 8 divided by 6 or 4 by 3, but this is hours. They have asked in minutes. They have asked in minutes. So 4 by 3 into every hour has 60 minutes. Okay, so this turns out to be how much? 80 minutes. Okay, this turns out to be 80 minutes. Correct? Answer is option number C. It is 80 minutes. Okay. Yeah. Test series will be there for EC and EE in Home Institute, right? Okay. So it is 80 minutes. This one is 80 minutes. Option number C. Is option number C. So that's what I told you. Sometimes, these two bodies, okay, two persons or two bodies, okay, working together, parallel formula XY upon X plus Y. Okay, like we apply to the first question here. Okay, now let us understand the concept, because the question may not be on 2 persons. Sometimes it can be easy. Okay, but if it is 3 persons, yeah, there can be negative work concept. For all that we need to understand efficiency. Okay, now suppose brain can do the job in 6 days, alone brain. Okay, he can do the job in 6 days. Okay, how does it work actually? Okay, he can do the job alone in 6 days. Okay, so in 1 day, I'll explain you this whole question with efficiency method. This whole question with the efficiency method. Just wait for a minute, okay? So, brain, let's say B, okay, or let me call it as brain. Okay, how much time he takes? He will take 6 days of time. Okay, 6 days to complete the work. Now, let us say work is 1 unit. Simply, let us assume the work is 1 unit. Okay, so what is the work done, okay, by this person brain in 1 day? Okay, what is the average work done by brain in 1 single day? In 1 single day, so see, he takes 6 days to complete whole work. Whole work is suppose 1 unit. So in 1 day, how much he completes? 1/6 of the work. That is 1 upon 6. That is 1 upon 6. In 1 single day, he will complete 1/6 of the work. Okay, this is what is known as efficiency. This is what is known as efficiency of a person. Work done by a person in 1 unit of time, not necessarily 1 day. Okay, work done by a person in 1 unit of time. Okay, in 1 unit of time. Say for example, okay, a person can complete a particular work in 2 days. Okay, so let's more simple example. If a person is able to complete the work in 2 days, okay, that means every day how much work he is doing? 50%, 50%. Okay, every day he is doing 50% of the work. Okay, so that his efficiency is 50%, or in the fractional form 1/2. Total 2 days, every day 1/2. So suppose a person completes the work in n days. Okay, then efficiency is 1 upon n. 1 upon n. So what is the efficiency, dear? Efficiency, if I define simple, is work done in 1 unit of time. I will not every time say that the question is on days. It can be hours, it can be months. Okay, sometimes we need months to complete a work. Okay, so efficiency is work done in 1 unit of time. That unit of time can be days, hours, months, years, weeks, anything can be given to you. Okay, So if you are able to complete a work in complete n days, okay, then in one day 1 upon n. So that means efficiency is what? Reciprocal of the total time taken. Clear? Reciprocal of the total time taken. This is number 1 point. So that is why I'm telling brain, okay, will do in one day 1 by 6. That is the efficiency of brain is 1 by 6. Next, LX can do the job in 12 days. Okay, LX can do the same job in 12 days. Okay, so what is the efficiency? Okay, so work done, I'm not writing the definition again. Work done, okay, in one day is equal to 1 by 12. Now they work together. Okay, now they work together. Okay, so if they work together, okay, okay, so if they work together, what is their combined efficiency? So each and every single day, brain will do 1 by 6th of the work, LX will do 1 by 12th of the work. Okay, so together, work done in one day. Okay, work done in one day. What I will call this as? This is known as combined or net efficiency. This is known as the combined or the net efficiency. Okay, so what is the net efficiency? 1 by 6 plus 1 by 12 work done in one day. Okay, so both are working together. So 1 by 6 plus 1 by 12 will happen. Okay, so how much is this? See, the LCM will be 12. This is 2, then this is 1, 2 plus 1. So this is 3 by 12 or 1 by 4. Now, if their net efficiency, if their combined efficiency is 1 by 4, so how much is the combined time taken? Reciprocal, na? As I just told you, efficiency is reciprocal of time taken. Okay, so what is the time taken? Okay, so what is the time taken? See here. So reciprocal of this, that is 4 days, and that is what I gave you the same answer in one single line. So if it is only on 2%, if it is only and only on 2%, then xy upon x plus y can be done. If it is more than 2%, okay, then we will generally apply the concept of efficiency. Very simple. Keep, sometimes you have LCM methods also, but I think no need to go to any LCM because negative work will also come. So efficiency method will help you solve everything, whether it is negative work. What do I mean by negative work? I will explain you shortly. Okay, I'll explain you shortly. Don't worry. Okay, fine. So let's move ahead to the next case. Okay, let us move ahead to the next case here. This is done. This question was directly done by the formula, and here it is the next question for you. A can lay railway station between two given stations in 16 days. Okay, right? Yes, Ashok and Krishna, correct answer for the previous one. B can do the same job in 12 days. A can lay a railway track between two given stations in 16 days. B can do the same job in 12 days. With the help of C, they did the job in 4 days only. Okay, with the help of C, they did the job in 4 days only. Then C alone can do the job. So there are 3 persons now. Okay, there are 3 persons now, but how much time is required by the third person alone is not given. Okay, but when they combine with the help of C, A and B, means ABC combined, they did the job in 4 days. Okay, they did the job in 4 days. Now guys, every time we should not write efficiency is equal to work done in 1 unit of time. In one single line, you have to solve the answer now. Okay, let's adapt speed now. Let us adapt speed now. Okay, good morning, Ashok. Okay, we are going to now adapt speed. Okay, now how do we, solve this quickly? Okay, what is the A? A is able to do the work in 16 days. So what is the efficiency of A? 1 by 16. Okay, then B can do the same job in 12 days. So what is the efficiency of B? 1 by 12. Okay, C can do the job in how many days? I don't know. Suppose C can do the job in n days. Okay, so what will be the efficiency of C? 1 upon n. What is given to you when they combine, the job is completed in 4 days only. Okay, so what is the combined efficiency? What is the combined efficiency? A reciprocal of time taken. So together they take 4 days. So their together efficiency, combined efficiency, net efficiency, any word you can use, together efficiency, total efficiency. Okay, so 1 upon 4. Okay, so from this we can find n. So just one line you have to write. You don't have to describe every time. Na? This is the meaning of efficiency. So A will do this much of work, B will do this much of work. No, one single line, write down the answer straightforward. Okay, so what is the value of 1 upon n? It is given by 1 upon 4 minus 1 upon 16 minus of 1 upon 12. Right? Okay, so now let's take the LCM here. 16, 12, 4. I think 48 will work. Correct? Okay, and this should be 12 and minus of 3 and 4 by 48. Okay, so 12 minus 3 minus 4, 12 minus 7, 5 by 48. Now this is 1 upon n. So what is the value of n? Is 48 divided by 5. That will be cancelled as 9, 3 by 5. My answer will be option number C. Okay. Yes, Ashok, that's what I told you. That is why we have come up with this idea, Super Sunday. It's not one special Sunday or one Super Sunday. Every Sunday you'll get something for aptitude, mostly aptitude or sometime maths. Okay, but mostly first we'll fix aptitude. Okay, and on weekdays I'm planning technical sessions. Okay, so Super Sunday time almost will be same, 11 a.m. times. 11 a.m. times. Okay. By chance, if I'm not available also, no, by chance, if I'm busy in offline class, okay, so then I'll try to record for that particular Sunday. Okay, right now this is live session, but by chance, if I'm, in offline class in any particular Sunday, I'll even try to make a recording so that every Sunday you get some practice session and step by step you cover up multiple topics of aptitude. Okay. Right. Okay, this is what the theme is. Let's move ahead to the next question. Okay, negative work. Now see, what is the meaning of negative work? Okay, yes, Ashok, correct answer. See, what is the meaning of this negative work? Let us understand. Okay, a tub can be filled in 20 minutes, but there is a leakage which can empty the tub. Now see, okay, if you open the tap, okay, what is the role of the tap? To fill, okay, to fill the tub. Okay, but there is a leakage in the bucket, okay, or in the tub, whatever it is. Okay, so there is a leakage. And if there is a leakage, what is the role of leakage? The water will keep flowing out. So somebody is filling the water and somebody is taking out the water. Like that you can say, na? Okay, filling and taking. That is what is happening. So dear, looking into that, I can say that the person, okay, the body who is emptying the tank is doing the work opposite to who is filling the tank, correct? Okay, now tub alone can be filled in 20 minutes. Okay, now the tub is suppose filled. Okay, but there is a leakage and that leakage can empty the full tub. That's what telling, na? Full tub. Suppose the tub is full, the leakage can empty in 60 minutes. Okay, now considering both, in how many minutes can it be filled? Okay, actually it should be filled in 20 minutes, but every minute it is filled, the same minute some leakage is also happening. So in how many minutes? Again, efficiency will save you here. Okay, what is going to be the net efficiency? I'm telling you, we will solve in one single line. Okay, what is the net efficiency here? Okay, net efficiency means, just let me write down, net work done in 1 unit of time. Now, what is the unit of time is? Minute. Okay, so work done in 1 minute. Now, what is the work done in 1 minute? Okay, tap is on. Okay, that will fill the tub, total tub in 20 minutes. So, in 1 minute, how much tub can be filled? In 1 minute, how much tub can be filled? It is 1 by 20. Okay. Now there is a leakage which can empty the tub in 60 minutes. So in 1 minute, how much can it empty? 1 by 60. So how much it is the net work done? How much is the net tub filled? Rather than work done, let me write here net tub filled. Okay, so this much is filled, but this much is leaked out. So this time what I should do? For efficiency, this time we have to minus. That is why commonly I use the word net efficiency rather than total. Total commonly gives you a perception that you have to add every time. No, it is net efficiency. Sometimes you have to subtract also if some particular body is doing the work in the opposite direction. Clear? So 1 by 20 minus 1 by 60. Let's take this as 60 and then this is 3 and minus 1, 2 by 60 or 1 by 30. Okay, now the net efficiency is 1 by 30. So what is the net time taken? Okay, or reciprocal of efficiency, that means 30 minutes. The tub, which could have been filled in 20 minutes, because of the leakage, it will now take 30 minutes to be filled. So, good, correct answer, Krishna and Ashok, good going. Okay, now it will be filled in the 30 minutes. Okay, dear. So, this is what negative work means. Next. Now, see, a question taken from GATE here, GATE 2-mark question. An oil tank can be filled by pipe X in 5 hours. Pipe Y in 4 hours. Each pump working on its own. Okay. When the oil tank is full and the drainage hole is open, the oil is drained in 20 hours. If initially the tank was empty and someone started the two pumps together but left the drainage hole open, how many hours will it take for the tank to be filled? Okay, to see. An oil tank can be filled by pipe X and pipe Y. So there are two pipes who are simultaneously filling the tank. Okay, pipe X alone will take 5 hours. Pipe Y alone will take 4 hours to fill that oil tank. Okay, each pump working on the own. This is the time given. When the oil tank is full and the drainage hole. So again, there is a drainage hole into it. Okay, to empty the tank, okay, to empty the tank. So what is the role of the drainage hole? Opposite work again, correct? It is going to do what? It is going to empty the tank, correct? It is going to empty the tank, right? Okay, so the oil is drained in 20 hours. If when the tank is full, again, when you like leakage, there is an intentional drainage hole. When I open it, the entire 20 hours is needed to empty the tank, to empty the oil tank. Okay, now if initially tank was empty and someone started the two pumps together but left the drainage hole also open, how many hours will it take? So simple, na? Okay, if initially tank is empty, right now it is at zero level. Okay, someone started the two pumps together. Okay, two pumps are together and drainage hole is also open. That means all three are working, but drainage hole, okay, is responsible for doing opposite direction work, negative work. So what will I do? I will directly, now again I will solve in one single line. Okay, what is my net efficiency? Okay, what is my net efficiency? Only that thing I will write. Okay, so two pumps are together. What is the efficiency of X pipe? 1 by 5. Okay, what is the efficiency of pipe Y? 4 hours, so 1 by 4. Okay, but drainage hole is also open. So what is the efficiency of drainage hole? Okay, drainage hole can empty the drain it completely in 20 hours. So in 1 hour, 1 by 20. But because it is negative work, so what will I do? I will subtract. Hope you have got the reason for subtraction. I will subtract. Okay, this now becomes 20 as the LCM. This is 4 and 5 and 1. Okay, so 9, 8 by 20. Okay, so what is the time taken? The time taken there is clearly 20 by 8, or that is 2.5 hours now. 2.5 hours, option number D. Now the time taken is the 2.5. Okay, so what is 2.5 hours it is? Okay, dear. Yes. Yes, the correct answer, Krishna Day, Ashok. Ashok, yes, correct answer. Okay, let's move ahead to the next question. Okay, let's move ahead to the next question. Okay, another question. Okay, again a good variety. This you have to little bit break into separate intervals. Let's understand this question. If it is not every time straightforward, then what can be the different variety? Okay. Don't worry, Ashok, we'll plan probability sessions also. We'll plan probability sessions, maybe PYQ sessions as you're suggesting. Okay, we'll plan on to it. Right now, if you're getting the answers to time and work, if you're learning, if you're enjoying time and work, do not forget to put your attendance. And what is your attendance? Of course, just a like button. Do not forget to hit the like button onto the session. Okay. Okay. So again, right now, again, we are into efficiency. We'll come now next to the, product constancy. Product constancy case also, will come to it soon, right? Okay, dear. Okay, yeah, two pipes P and Q can fill a tank in 6 hours and 9 hours respectively, while a third pipe R can empty. Okay, so again, third pipe R responsible for emptying, P and Q responsible for filling. This is positive work, this is opposite direction, negative work. Their individual data is given. Initially, P and R are open for 4 hours. See, in the previous question, it was mostly simple because all three were open simultaneously. But here, for the first 4 hours, okay, P and R, okay, that is one filling and one emptying, okay, are open. Then P is closed and Q is open. Okay, again, Q means filling and R is emptying. Q is open. After 6 hours, R is closed. Okay, R is closed. So that means only Q will be left. Okay, the total time taken to fill the tank. Okay. So you have to break here. Okay, so what is the data for the first 4 hours? P and R are open for the first 4 hours. Okay, so see here. Okay, let's solve here. And what is the data for the first 4 hours? Tell me. Okay, for the first 4 hours, who are open? Okay, P and R. Okay, so what is the work done by them? What is the efficiency of P? See, if any doubt, please let me know how I'm going to write the equation. Please see. P, okay, will fill the tank in 6 hours. So what is the efficiency of P? 1 by 6. And what do I mean by efficiency? Work done in 1 unit of time. Work done in 1 hour here because the unit of time is hours. Okay, so in 1 hour, P will fill 1 by 6 of the work. Now R will do the empty, opposite work. R needs total 12 hours, okay, to empty the tank. In 1 hour, 1 by 12. In 1 hour, 1 by 12. Now I will subtract this. Okay, but this is their combined efficiency, net efficiency of P and R. That is the work done in 1 unit of time, 1 hour. Okay, but they are working together for 4 hours. So what I should do logically? Every hour this much of work is done. Every hour this much of work is done. So how much work is done in 4 hours? Into 4 I will do. Every hour this much work done. Okay, so this should be equal to how much? Okay, this is 12 to minus 1 into 4. Okay, so this is basically 1 by 12 into 4, 4 by 12, 1/3. Basically 1 by 3 should be the equation left out, correct? Yeah, this is 1 by 3 in the first 4 hours. Now next what happens? Okay, then P is closed and Q is opened. Okay, after 6 more hours. So this trend will be there for 6 more hours. Okay, so now we have next 6 hours. What happens in the next 6 hours? See, they were open for 4 hours. Okay, then P was closed and Q is open. To who is working now? Q along with R. Okay, and this happens up to the 6 more hours. So next 6 hours, Q and R are working together. Q alone can fill the tank in 9 hours. Okay, so efficiency of Q 1 by 9, efficiency of R minus 1 by 12 because this is negative work. Okay, this is the combined efficiency, work done in 1 hour, 1 unit of time. So in the complete 6 hours, they will do, in the complete 6 hours, they will do 6 times this much of the work. Okay, so this is how much? This is going to be how much? This is like 6 by 9, 2 by 3 minus 1 by 2. Minus 1 by 2. So this is like 4 minus 3, 1 by 6, 1/6. Okay, this should be 1 by 6, correct? Okay, then after this 6 hours, R is closed. Okay, and now alone Q will be open. Okay, how much time is needed to fill the tank? So how much is the work done till now? Okay, how much is the work done till now? See, this is total 10 hours. 4 and 6. Okay, in 10 hours, how much is the work done? In these 10 hours, how much is the work done? 1 by 3 plus 1 by 6, and that should be equal to how much? Okay, this should be equal to 1 by 2 actually. Okay, after solving, yes, correct. This is 1 by 2. Okay, so in the first 10 hours, half of the work is only done. Okay, now how much time is needed to fill the tank? Okay, how much is the work left? How much is the work we have assumed? 1 unit. Okay, the work left is half is done, so 1 minus half is left. Okay, so 1 by half is work done, and this is to be finished by Q alone now. Okay, because R is also closed. Okay, R is also closed after 6 hours. Okay, so who will do Q? Now Q needs 9 hours. Q needs 9 hours to complete the work. Okay, Q 9 hours for complete work. Simple equation. 9 hours for complete work. Now how much time needed for half work? Okay, so 9 by 2 hours for half work because only half of the work is left. Okay, half of the work is left. So how much time he takes? 9 by 2, that is 4.5 hours. Okay, now question is asking what is the total time? See, even 4.5 is not in the option. Okay, but even if it was in the option, it becomes risky if you don't read the question clearly. Okay, the total time taken. See, not the time now needed. Okay, not after this, starting from the beginning. So 10 hours were already done. 10 hours were already done. Okay, remaining this is additional 4.5. So that is why the answer is 14.5. Now the answer is 14.5. This is option number C. Hope the logic is clear to you. Option number C. Okay, for every question we have an answer, and that is efficiency. For each and every question we have an answer, and that answer is efficiency. That answer is what? That answer is efficiency, correct? Yes, Ashok and Krishna, they very correct answer. The answer is efficiency for each and every such question. Now let's move ahead to the next. Okay, fine. Yeah, next. Now product constancy. I told you 2 concepts. If you learn, all your questions will be solved. First one was efficiency. Now we have product constancy. Now we have the product constancy. Okay, now let's see what is this product constancy actually. Okay, so see, what do I mean by product constancy is Suppose if I talk about work, can I say more men? See, it's not only about men. Okay, the work can be done by men, women, okay, children, okay, machines, computers, tractors, anybody can do the work. But to define the formula, we normally say the work done by men. Okay, so can I say more men will do more work? Right now, tell me if there is any objection. Okay, so more persons will do more work. The work is proportional to number of men. Okay, now suppose more the time, more will be the work done. Suppose the number of persons is fixed. Okay, but if you give more time, okay, the more work will be done. The work is also proportional to time. Time means days. Okay, the work is also proportional to days. Okay, 4 days, or if you keep working for 6 days, you do more work. Okay, same person with same efficiency. Okay, if he works for 4 days, some work is done. If he work for 6 days, some more work is done. If he work for 10 days, some more work is done. Right now? Okay. Now, not only this, work also depends on hours per day. Hours per day, right? Okay, suppose someday I worked only 6 hours, another day I worked for 10 hours. So of course, whenever I work for 10 hours, I have done more work. Okay, with the same efficiency, I have done the more work. Okay, so it also depends on works hours per day. Also, okay, now work depends on what? Okay, now there are two persons with different efficiency. Okay, who will do more work? The person with more efficiency. Okay, suppose A needs total 2 days of time, B needs total 4 days of time. So what is the efficiency of A? 1 by 2. What is the efficiency of B? 1 by 4. So in every single day, how much work is done by A? 1 by 2, 50%. How much work is done by B? 1 by 4, 25%. Who is doing more work? Who has the more efficiency? Okay, so work is very clearly also proportional to efficiency. Is also proportional to efficiency. Okay, it is also proportional to efficiency. That means combining all of these factors, work is proportional to, okay, men, days, hours, E. Let me in short write it as MDHE. The work is proportional to MDHE. Or let us make a simple equation. Okay, work, now remove proportionality sign, we introduce a constant of proportionality K, MDHE, but this is our defined equation. We can choose our constant of proportionality. Okay, so let's say the K is 1 and we can write down work as MDHE. Now, how to use this equation? Okay, how to use this equation? And a very common version of this. See what I have told you. Work is MDHE. Okay, now suppose, okay, if H and E are fixed, if efficiency is fixed, means are same. Suppose number of working hours per day and efficiency are same. Okay, so then I can say that work is equal to men into days. Okay, the basic concept that is known as the concept of men into days. I call it as the concept of product constancy. In some books, you may find the concept as men into days. This is known as men into days concept. Now, what happens with this men into days? Okay, this brings simple question, but more better questions can be solved with the complete equation MDHE. Now, how this men into days will help you? Let's understand through a question. What is this men into days? Okay, 25% can do a piece of work in 8 days. Then how many persons can complete the same work in 20 days? Now see, the work was to be completed in 8 days, but now suppose you have more time, okay, and you have the same work, okay, same amount of work, and you have flexibility, you have more time. So of course, if you have flexibility, if you have more time to complete the work, you need less labor, you need less number of persons. That is what, you need less number of persons. Okay, the same work. Okay, so when I say this same work, what I mean is W1 is W2. Same work. That is what is men into days. M1D1 equal to M2D2. Such simple questions can be solved by this equation. M1D1 into M2D2. Okay, that clearly means that because the work is same, okay, the men is inversely proportional to number of days. So if I give you more time to complete the work, number of men will reduce. They will be inversely proportional to each other. Okay, so initially 25 persons were able to complete in 8 days. Okay, but now I don't know how many persons, but I have the time to finish the work in 20 days. So tell me how many persons are required? 25/8 is 200. 200 by 20 is 10. Okay, how many? 10 persons are required. Okay, 10 is the answer. Okay, 10 is the answer. Very simple. Okay, they are inversely related to each other. That is what is men in today's. Simple questions will be only using men in today's. Otherwise, MDHE is the general concept that can be used. Okay, MDHE. MDHE. Now let's move ahead. Look into it. 25 men can do a piece of work in 36 days, working 10 hours a day. Then how many men are required to complete the same work, working 6 hours a day in 20 days? Come on. Let's see. If 25 men can do a piece of work in 36 days, working 10 hours a day, then how many men are required to complete the same work? Again, you see the important line is same work. Working 6 hours a day. Working hours is different. Okay. Working hours are different. Now, if the working hours are different, okay, what will be the work to be used? Okay, use the work as number of men is different. Okay, number of days are different, 36 days and some other days, and working hours per day. Okay, efficiency, nothing mentioned. Okay, efficiency will differ. Suppose on one side they give you men, other side they give you women. Okay, or if one side it is men, one side it is, boys. Okay, their efficiency will of course be different. Okay, but here 25 men and here also men. Okay, men versus men, the same efficiency. Okay, same efficiency. Okay, so efficiency not required, efficiency will be same. If men versus women, men versus boys, boys versus girls, okay, or men versus a tractor, machines, okay, all that will have different efficiency. And what is that efficiency will be somehow directly, indirectly specified. Now you see, okay, so what will I use? Product constancy M1 D1 H1 will be equal to the M2 D2 H2. This is the equation to be used. In the first case, 25 men. In the first case, the number of days taken is 36, and in the first case, we are working 10 hours a day. This is equal to how many men? I don't know, M2. Okay, but in the second case, they will be working for total 20 days, and every day 6 hours a day. Of course, now see, working days. How many days they work? That is also reduced. Per day they worked, that is also reduced. So now the number of men should definitely be more. So Ashok and Ashok, both Ashok come up with the answer 75, right? Definitely it will be more because the time you have reduced. Na? Okay, so more labor is required. Okay, simple logic. Okay, so what is going to be M2? Okay, so see, this is 6 cancelled here. This is 36 and 6. Okay, 25 into 6, 63, 25, 3, 75. Yeah, correct. 75 is the correct answer. 75 men will be required. 75 men will be required. Hope that is very clear to all of you. Okay, any doubts, please keep posting to me. Okay, a group of workers estimated to finish a work in 10 days, but 5 workers could not join the work. It happens sometimes. Okay, a contractor planned to complete a work with his group of workers, group of laborers, but some of them at the end moment, they joined some other work or they had some other things to do. Okay, they could not join the work. Okay, so if suppose those group of workers joined, work was to be finished in 10 days. Okay, but 5 workers could not join. Okay, could not join. Rest of them finished the work in 12 days. Then determine the number of workers present in the team. Okay, so again, only number of men and number of days is mentioned, no hours. If there is no hours per day mentioned, we assume equal. Na? Okay, and it is same category of worker, efficiency same. Okay, so what is this concept again? This is again M1 D1 equal to M2 D2. M2 D2, simple question again. Okay, originally, okay, determine the number of workers present in the team originally. Suppose the number of workers in the team originally was N. Okay, so these N workers were supposed to complete the work in 10 days, but how many could not join? 5 did not join the work. Okay, so how many actually worked? Tell me. Okay, 5 did not join. How many worked? N minus 5 worked. Okay, for how many days? Okay, because 5 labors were reduced, so time taken is slightly more, that is 12. By this equation, we can find the value of N. By this equation, we can find the value of N. 10N is equal to 12N minus 60. 2N is 60. N is 30. Okay, originally how many workers were present in the team? 30. But 5 could not join. The 25 worked. Less people worked, so more time was taken. Okay, 12 days rather than 10. 12 days. We can find the value of it. 10N is equal to 60. 2N. Okay, ji. This is what it is. This is what it is. Let's move ahead to the next case. Let's move ahead to the next case. Yes, Krishna, correct answer. Ashok, correct answer. 30. Yeah. A GATE 22 mark question. It was estimated that 52 men can complete a strip in a newly constructed highway connecting cities P and Q in 10 days. Okay, it was estimated that 52 men can complete a strip in a newly constructed highway, okay, connecting the cities P and Q in 10 days. Okay, if 52 men work 10 days. Due to an emergency, 12 men were sent to another project. Like in the previous case, 5 did not join. Here 12 intentionally were sent to another project. Okay, that means here 52 minus 12 people worked. How many number of days more than the original estimate will be required to complete the strip? Okay, so of course, because number of workers reduced, okay, time taken will be more. Number of workers reduced, now the time taken will be more. Okay, what is that more time? Okay, what is that more time? Let us see. Okay, so again here, no efficiency, nothing mentioned. Okay, what we will use is again M1 D1 is equal to M2 D2. Okay, dear, what is the M1? Okay, originally 52 men, okay, were required to complete the work in 10 days. See, simple question also coming for 2 marks if you know this men in 2 days. Okay, now due to emergency 12 were sent to another project. So how many worked? 52 minus 12. How many worked? 52 minus 12. They worked for how many days? I don't know, but less people work, so more time will be taken. Let's see how much it is. Okay, so this is 52 into 10 is equal to 40 into D2. So how much is D2? Okay, 52 by 4 should be equal to 13. Okay, so how much now time will be taken? 13. Okay, is the answer 13? Is the answer 13? Now, so I'm telling you, na, questions sometimes can make you fall into trap. Even despite of all your knowledge, you know time and work, you know product constancy, so you might feel it's a simple, and actually 2 mark it's a simple question, but see, read the question very carefully. Read the question very carefully. 13 is not the correct answer. Question is, how many number of days more than the original estimate will be required? Okay, how many more than the original estimate? Originally the estimated time was 10 days. So 3 days. Answer is 3. See, a simple language can fall you into a trap. Okay, so what will I say here? Okay, total 13 days. That means 3 days more than the original estimated time. 3 days more than the original estimate. Correct answer is option number D. The very correct answer is option number D. Yes, it's a simple but very logical mistake. Many times students will do it. Many students will do it actually, but that's what you have to read the language. And see here, both are available in the option. That's even a big trap. If 13 was not there in the option, you rethink. Okay, but here in the flow, you might take 13. Array, I know I've done everything correct. Okay, dear. If I only say, na, how many number of days will be required? If I cut this line, how many number of days will be required to complete the strip? Then your answer is 13. Okay, but how many number of days more than the original estimate? So 3 more than what was estimated time given to complete the work. Okay, next question ready for you. Okay, now teamwork. Okay, now let's come to the next category, that is the teamwork. Okay, 5 men. Okay, now why I'm going to teamwork? Because there are men, there are women, and there are boys. Okay, they will be clubbed. Teamwork question. Okay, 5 men can paint the building in 20 days. Okay, if 5 men alone will do the job, they will paint the building in 20 days. 8 women can paint the same building, that means same work, in 25 days. 10 boys alone can paint the building in 30 days. Now there is a team which has 2 men, 6 women, 5 boys. How long will it take to paint the building? How long will it take to paint the building? Now you see, okay, suppose 5 men are there, na? Okay, suppose if there is a single man, even is the efficiency. Okay, single man efficiency. Okay, for women, it is suppose E2, and for boys, it is suppose E3. Because there are 3 different types of persons, men, women, boys. Okay, they will have different efficiency. Here we can't assume same efficiency, correct? Okay, we can't assume same efficiency. Okay, now 5 men can paint the building. So what is the work? The work is to paint the building. This work can be done by how many men? Okay, see what all is required. Number of working hours is not mentioned. Working hours per day not mentioned, so that we will assume same. Okay, so what is the work I will use? Okay, I will use number of persons are given, suppose M, into days. Yeah, somebody will do in 20 days, somebody will do it in 25 days. And efficiency E is given. And efficiency, that is E is given, correct? Okay, efficiency E is given. Okay, so in the first case, 5 men, okay, will do the job in 20 days, okay, with efficiency E1. Okay, so the work is 100 E1. Okay, same work, same building, okay, can be painted by 8 women in how many days? 25 days, okay, with efficiency E2. So this is 200 E2. Okay, same work can be done by 10 boys, okay, in how many days? In 30 days with efficiency E3. This is 300 E3, correct? 300 E3. Okay, so if all these three are equal, we can find the relation between their efficiency. Okay, if all these three are equal, what I can say is, because same work, na, so 100 E1 is 200 E2 is equal to 300 E3. Okay, or cancelling the 100 factor, E1 is equal to 2 E2 is equal to 3 E3. This is E3, correct? Okay, I have the relation between all the three efficiency. Now let's come to the team, dear. Now let us build a team. What all is there in the team? What is there in the team? 2 men. Okay, 6 women and 5 boys. Now see, dear, there is a team of 2 men, 6 women and 5 boys. Okay, how long will it take to paint the building? How long will it take to paint the building in this case? Okay, in this case, if they work as a team, how many team? With 2 men, 6 women and 5 boys. Okay, so with this team, okay, the work that can be done is how much? 2 men. Okay, work is how much here? MDE. MDE. So how many men? 2 men. Okay, suppose they are working for how many days? I don't know. How long will it take? That is what I need to find. Okay, so suppose the team, suppose the team, completes the work in D days, in D number of days. Okay, so because it is a team, men, women, boys, everybody work for same D number of days. Okay, but efficiency of men is E1. Then next, 6 women, because they work as a team, the work will be combined, they work together. Okay, like we add efficiency. So how many women? 6 women. How many working days? D. Okay, efficiency of women E2. Next, 5 boys, they work for D days, efficiency E3. Okay, but now this work, this work can also be written as E1. Let's convert everything to E1 because we know the relations between E1, E2, E3. So this work is 100 E1. This is equal to, now D is common, so 2 E1 plus 6 E2. What is E2? E2 can be written as E1 by 2. Everything converted on E1. Okay, plus 5 E3. What is E3? E3 can be written as E1 divided by 3. E1 divided by 3, D common. So now that is what E1 also can be cancelled. So I have just left with the equation 100 is equal to 2 plus, that is 6 by 2, 3 plus 5 by 3 whole multiplied by D. Okay, solve this up. So 100 is equal to 5. 3 5s are 15 plus 5 to 20 by 3 into D. Solving this, we get the simple answer. D is equal to 300 by 20, 15. Okay, so how much time is needed by the team? 15 days. How much time is needed by the team? 15 days. See, this is another concept where teamwork will come into action. Correct answer is option number D. Correct answer is option number D. Okay, the very correct answer is option number D. Correct answer is option number D. Yes, Ashok, correct answer. Okay, dear. Chalo. Now, if you have understood this teamwork concept, I will, first like to give you a homework here. It's a GATE 17. Okay, GATE 17 IIT Roorkee year. Next year is also IIT Roorkee only. Okay, 1200 men and 500 women. Okay, team. Okay, the data is starting with team only. Okay, can build a bridge in 2 weeks. 900 men and 250 women can, will take 3 weeks to build the same bridge. How many men will be needed alone to build a bridge in 1 week? Now, initially team data is given. You need data alone for men. How many men will be needed to build a bridge in 1 week? Please solve the homework, and there is a request, as you solve the homework, do mention your answer in the comment box. Okay, after the video gets over, not in the live chat box. Please mention your answer in the comment box, and I'll also revert whether your answer is correct or not. Okay, let's make the comment box interactive. Okay, please solve and mention your answer in the comment box. And guys, like every other sessions, for these Sunday Super Sunday sessions where we are practicing aptitudes, general aptitude practice dose. But as you saw today, it was not only a practice dose with every question coming up. Before that, I explaining you the concept. What is efficiency? What is product constancy? The concept will automatically be there. Aptitude is of course more about practice, so I call it as a practice dose. But whatever background is needed, whether it is in the form of concepts or shortcuts or tricks, everything will be given to you so that you learn that particular concept. Okay, now other than that, time and work, all PYQs you practice, I think it is enough. You don't need anything more. You just follow this class and time and work PYQ, I think it is enough. So like this, every Sunday to Sunday we'll keep taking, and like every other session, I'll provide you the PDF, whatever we learned today, the concepts, the question, the detailed solution, everything that I have written here, you will get it in the PDF. Okay, and as always, my rule, the PDF will be password protected, and the password will be randomly. I think about the password, and what is coming to my mind is team. Just now we solved a team based question. Team, everything in small. Okay, everything in small. Okay, everything in small. Okay, right, everything is going to be in small. Okay, and where will I share the PDF? I'll share it in my Telegram group. Let me just share you the link of my Telegram group. Just a second. Okay, I'll just share you the link of the Telegram so that yeah, just confirm me if you have received the link, received a Telegram link. If you are not connected in my Telegram, you can join this Telegram group, because I'll be sharing the PDF in this particular Telegram group only, right? I'll be sharing you the PDF in this Telegram group only. Okay, fine. Okay. All right, dear. Chalo. Okay, so this is the password, TEAM, everything in small. Okay, note down the password. Those who watch the idea of password is those who watch the session, they see the password, and I think those who watch the session, they only need the PDF, they only need the notes. Otherwise, if you're not following the class, then the notes are not for you, very clearly. Okay, this is one homework. Try the homework and mention your answer in the comment box, okay, after the video gets over. Okay, that's it from my side, guys. Thank you for attending the session. Okay, you can be connected with me in the Telegram. I've shared you the link, and this is also the name mentioned. If you can directly search using this name also, you will be landed in my Telegram group, and I'll share you the PDF after some time in the Telegram group. Okay, guys, that's it from my side. See you on the next Sunday with some more aptitude practice dose. And other than that, weekdays, very soon you'll have some technical sessions from this weekdays only. Next 2-3 days, okay, some practice sessions for technical important practice sessions. Okay, I am building for you. Okay. Chalo. Okay, dear. Bye bye. Thank you. Stay safe and do take care of yourself.